Unit 4 Wave Propagation. In this session, we shall be discussing about how the waves propagate in the atmosphere. Here, the wave represents or wave means the electromagnetic waves, the signals, the information signals, how the information signal or any kind of a signal propagates from one place to another, from transmitter to the receiver. So we will be discussing wave. If we say that it is not a wave or information signal, then it is simply the noise. But the meaningful information will be considered as wave or electromagnetic waves or signals. Before heading towards the content of wave propagation, we will understand the very first diagram we have studied, the block diagram of the communication system. So, the block diagram of communication system consists of information source, transmitter, receiver. Transmitter and receiver are connected by channel. Then receiver, after receiver we have destination. Noise is always connected with channel. Noise can be added to transmitter also, receiver also. But noise has the highest effect on channel. Now we will see the function of each block one by one. Information source means the message or the information or the low frequency signal or the modulating signal which is electrical in nature. This is very important. The information must be in electrical in nature. If it is not electrical in nature, we cannot transmit it through wired or wireless media to a longer distances. So, how we will convert the physical information to electrical information? This can be done by using transducer. What is a transducer? So transducer is a device which will convert physical quantity or physical signal into electrical signal and vice versa. So the electrical signal or electrical energy which will be also considered as modulating signal or the low frequency signal or the message signal or the information signal will be transmitted by using the transmitter. Now what is the function of transmitter? The transmitter does the process of encoding and modulation. Encoding and modulation we can consider one at the same thing, they are synonyms to each other. But whenever the process of modulation takes place in the transmitter, there is a chance that there will be distortion. Now, what is the meaning of distortion? Distortion means undesirable change in the information signal. Undesirable change. Now, what is modulation? Modulation means, in very simple terms, converting a low frequency or the information signal to the higher frequency signal. This can be achieved by the process of multiplication. So in the modulation process, we have multiplied, we have superimposed a low frequency information signal over a high frequency carrier signal. This carrier signal will vary as per the amplitude levels of the modulating signal, and correspondingly amplitude modulation or frequency modulation or phase modulation process will take place. Then we have receiver. The receiver does the opposite of the transmitter, the receiver will receive the signal. The received signal is a modulated signal. So we have to decode it. So decoding can be done by using the process of demodulation. Now what is demodulation? Again, demodulation means opposite of modulation. Modulation means converting the low frequency signal to high frequency signal. So demodulation means converting the high frequency signal into the low frequency signal. But again, there is a chance that distortion or undesirable change may occur in the information signal. And finally, through all kinds of filtration activities, original signal can be reconstructed at the receiver and hence can be given at the destination. The destination can be any output device such as a speaker, such as a display unit, etc. Now, if it is a speaker, then again it is a transducer. It will convert the electrical energy into the physical quantity. Say, for example, if the at input side audio signal which is physical in nature is converted to electrical signal by microphone is a transducer. It will convert physical quantity or audio signal into electrical signal. Then at the destination we will have the speaker is again a transducer. It will convert electrical signal into the audio signal. If input is a video camera, then the output will be a video display unit. Then we have channel which is connecting the transmitter and the receiver, which is connecting transmitter and receiver. So the channel where the information is transmitted to the receiver. So it is a media. It can be wired or a wireless. So if the media or a channel is wired, it can be copper wire, it can be coaxial wire, it can be a pair of twisted cable, it can be optical fiber cable. And if the channel is wireless, then air and Earth's atmosphere will act as a wireless media. And obviously, the noise has the highest effect on the channel. Noise source. Noise can be external, noise can be internal. We have seen the external noise sources such as atmospheric noise, extraterrestrial noise, etc. Internal noise generated because of the electronic devices. So these all sources of noise generates the noise and gets added to the channel. So distortion occurs in the transmitted signal, and the receiver must be in a position, it must be capable of reconstructing the original information which is transmitted by the transmitter. So this is all about the communication system. So this was the first block diagram of the communication system and the channel between the transmitter and the receiver of the communication system, and suggested that signals are conveyed through this medium to the receiver. So in radio communication, the channel is simply the physical space. It is a physical space between the transmitting and the receiving antennas. So if I want to transmit a signal from transmitter to receiver via wireless media, then we require an antenna at both transmitting side as well as at the receiver end. Now again, what is the meaning of antenna? So antenna is a device, we can say a device which is formed which is made of single conductor or a group of conductors, which is capable of transmitting the information in space. Means it will again convert the, we can see it will again convert the frequency which are comparatively low, they are not having sufficient intensity to get transmitted in the air. So this antenna will convert, again we will say, the low frequency to the high frequency signal, so that they can be propagated in the atmosphere. And the behavior of the signal in that medium is referred as wave propagation. So the behavior of the signal in the medium in which they are transmitted or propagated is called as wave propagation. So when electric power is applied to a circuit, a system of voltage and current is set up in it, with certain relations governed by the properties of the circuit itself. Thus, for instance, the voltage may be high compared to the current if the impedance, here the impedance means the AC resistance of the circuit, is high. Or perhaps the voltage and current are 90-degree out of phase because the circuit is purely reactive. So there is a phase difference between the voltage and current. If the circuit is reactive, means it can be inductive, it can be capacitive. The current is lagging by 90-degree with voltage if the circuit is inductive, and the current is leading to the voltage if the circuit is capacitive. And there is no phase difference between the voltage and the current if the circuit is purely resistive. In the similar manner, any power, any energy, any power escaping into the free space is governed by the characteristics of free space. Now what is the meaning of free space? We'll see further. If such a power means, if such a power here means if the information signal, okay, if such a power escapes on a purpose, because power contains the information, hence we say it escapes on a purpose, it is said to have been radiated. Means if any signal escapes from its conductor, it is said to be radiated, and then it propagates in the space in the shape of what is known as electromagnetic waves. So what is the meaning of electromagnetic waves? Simply, the electromagnetic waves means the power which is radiated, the power which is radiated. Radiated means it is escaping into the free space for a purpose, and it is propagating in the space, then it is said to be electromagnetic wave. Why it is called as electromagnetic wave? Because whenever electric current is applied to a conductor, a magnetic field is set up. Also, an electric field is set up around it. Hence, here the conductor is the atmosphere, or the, we can say, space, and the information signal or the power which contains the information is our current. So free space is that space which does not interfere with the normal radiation and the propagation of radio waves. So free space means a space which will not interfere with the normal radiation and propagation of radio waves. Thus, It has no magnetic or gravitational fields, no solid bodies, no ionized particles. If there is no magnetic field, no gravitational field, no solid bodies, and no ionized particles in the space, hence it will not interfere with our information signal, and hence it is called as free space. The free space is unlikely to exist anywhere. It cannot exist. It does not exist near the Earth's surface because there are many things which are surrounding the Earth's surface. Say we can say planets. Sorry, they are outside the Earth's atmosphere. We can say the satellites, the meteors, the tall buildings. Of course, the tall buildings, the ionosphere, the mountains. These all will interfere in the propagation of the radio waves. Radio waves means the high frequency signals. However, the concept of free space is used because it simplifies the approach to the wave propagation. And it is possible to calculate the conditions in the space where it is free. And then we can compare, we can predict its effect of its actual properties. So it just acts as a reference for comparison with the actual properties. The propagating conditions sometimes do approximate those of free space, particularly at the frequencies in the upper UHF region. Now, what is the meaning of upper UHF region? Ultra high frequency region. Okay, we have seen the electromagnetic spectrum in the previous sessions. So there you can see the frequency range. So radiation and propagation of radio waves. So we cannot see by our naked eyes. We cannot see by any means. Hence, the theory of electromagnetic radiation was proposed by British physicist James Clerk Maxwell in 1857, and it was finalized in 1873. So who proposed? James Clerk. Electromagnetic radiation theory was proposed by him during 1873. And it is the fundamental mathematical explanation of the behavior of the electromagnetic waves. Now we will see the fundamentals of the electromagnetic waves. So electromagnetic waves are energy that are propagated through free space. Now here we see the definition of the electromagnetic waves. So what are electromagnetic waves? They are energy signals which are propagated through free space. What is free space? The space which does not interfere with the propagation of the signals. Okay, so electromagnetic waves are energy propagated through free space at the velocity of light, that is approximately 300 meters per microsecond, or we can say 3 lakhs kilometer per second. Actually it is 2.98 lakh kilometer per second, but we have approximated it to 3 lakh kilometer per second. Now visualize yourself standing on a bridge looking over a calm water body. If you drop a stone or object which does not float, you would see this energy process in action. As the object traveled downwards, there would be a path of bubbles generated in the same direction. If I drop from upwards, the bubble will come upwards. Okay. So as the object travel downwards, there would be a path of bubbles generated in the same direction as the object. But there would also be a circular wave pattern radiating, as you can see in this picture, from the point of impact and spreading horizontally across the body of the water. So in this diagram you can see that as we drop an object, a circular pattern is generated and it will spread across the water body. So this pattern, we can compare it as a radiation pattern. And this pattern is spreading horizontally across the body of the water. So a pattern is formed on the surface of the body as well as inside the water body. This picture shows how the light travels. It is just conceptual. So these two energy reactions approximate the electromagnetic and the electrostatic radiation pattern in the free space. The energy created by the displacement of the liquid is converted into both vertical as well as the horizontal component. The energy level of these components varies inversely to the distance. That is, the horizontal wavefront covers a larger area, as we can see in this picture, considering the no losses due to friction or obstacle, and spreads the total energy generated over this expanding wavefront, reducing the energy in any given section dramatically as the wavefront expands. And it's gradually reduces to zero as we move away from the point of contact. So as the object strikes, waves are generated and the energy is maximum at the point of contact, and it reduces dramatically as we move away from the point of contact. So this action can be related to the term power density. So power density can be defined as radiated power per unit area. It follows that power density is reduced to 1/4 of its value when distance from its source gets doubled. Means what? If the distance from the source is doubled, the power density reduces to 1 by 4. Distance gets doubled, power density reduces to 1 by 4. Now the direction of the electric field, the magnetic field, and the propagation are mutually perpendicular to each other. So these diagrams represent transverse electromagnetic wave in free space. Both these diagrams are exactly same, just to show here in this black and white diagram, the vertical lines represents the electric field, the horizontal lines in the y direction represents the magnetic field or the magnetic component. So this is color diagram so that you can distinguish between the electric and magnetic field. So why it is called as transverse electromagnetic field? Because the magnetic field, the electric field, and the direction of the propagation of the wave, here in this black and white diagram, z is the direction of the propagation of the wave. Here, both these, all the three components are mutually perpendicular to each other, as the electric field, the magnetic field, and the direction of the wave propagation is mutually perpendicular to each other. Hence, the name is given transverse electromagnetic wave. This is again representational image, how the wave propagates, what is the magnetic field. Here the brown color waveform represents the magnetic field, blue color represents the electric field. See, you can see here the angle between magnetic field and electric field is 90-degree, as well as the propagation is perpendicular to both electric field and the magnetic field. The distance between the two crests, the two peak values of magnetic field or electric field, is called as lambda, or the wavelength. So this is a theoretical assumption, this diagram and this diagram. So it is a theoretical assumptions, and it cannot be checked or verified since the waves are invisible. But practically we can confirm that electric magnetic field and the wave propagation direction, they are mutually perpendicular to each other. So it may be used to predict the behavior of electromagnetic waves in all circumstances, such as reflection, refraction, and diffraction. And this will be discussed later in the classes. If not possible, I'll give it in appendices in the notes. So this assumption, this transverse electromagnetic waves are invisible, but their behavior can be studied in the other circumstances such as reflection, refraction, and diffractions. Now, waves in free space. Since no interference or obstacles are present in a free space, electromagnetic waves will spread uniformly in all directions from a point source. The wavefront is thus spherical and is shown, the cross sectional is shown in this figure. So this is a spherical wavefront from a point source. So this is a point source. Let us denote this point source. So let us denote this point source as O. Imagine the rays which are radiated from the point source in all directions. But here only two rays are shown, but from this point source, all the rays are radiating in all the directions. In all the directions. They are everywhere perpendicular to the tangential plane of the wavefront, just like the spoke of wheel. So at the distance corresponding to the length of ray P, the waves has certain phase. So it may have left the source at an instant when its voltage and current were maximum in the circuit feeding the source. That is, at an instant of maximum electrical and magnetic vectors. So if the distance traveled corresponding to exactly 1,25,000 wavelengths, the instantaneous electric and magnetic intensities are that moment zero at all such points. This is virtually the definition of the wavefront. That is, it is the plane. It is the plane. What is a wavefront? So wavefront, it is a plane joining all points of identical phase. So here there are two wavefronts. Wavefront P, wavefront Q. Wavefront P for the ray P, wavefront Q for the ray Q. So there can be infinite wavefronts because there are infinite rays which are radiating out from the point source O in all directions. Here we have shown only the two wavefronts which are spherical. So it is the plane joining all points of identical phases. Here the wavefront is spherical. If the length of the ray Q is exactly twice of that of ray P, then the area of new sphere will be 4 times the area of the sphere with radius P. The point is, as the distance of the wavefront increasing, it's a doubling, then the area of the wavefront gets 4 times. Here the ray and P are double to each other. The ray Q is double of ray P. Hence the area under the wavefront P is smaller as compared to the wavefront of ray Q. How much it is smaller? The area of new sphere will be 4 times the area of sphere with radius P. Means if this radius is 1, then if the area is 1 for ray P wavefront, then the area will be for radius Q, the area will be 4 times. Means it is 4. Hence, the total power output of the source has spread itself over 4 times the area when its distance from the source has doubled. Distance is doubling, total power output of the source has spread itself over 4 times the area. So if power density is defined, now it can be defined as radiated power per unit area. It follows that power density is reduced to 1/4 of its value. The power density is reduced to 1/4 means 1/4 of its value when the distance from the source is doubled. Hence, power density is inversely proportional to the square of the distance from the source. And this is called as inverse square law, which applies universally to all forms of radiation in free space. So mathematically, we can state this as we have power density is equals to the total power transmitted, and as the area is spherical, so its area is 4 pi r square. So PD represent the power density at a distance r from an isotropic source, and PT is the transmitted power. So what is now the meaning of isotropic source? So isotropic source is that source which will radiate its energy uniformly in all the direction in the space. Although there is no practical source has this property, but the concept of the isotropic radiator is very useful in calculating the various terminologies, various power relations, beam weight, etc., and it is frequently employed. So what is the isotropic source? It is a source which radiates uniformly in all directions. in the space. So isotropic source practically does not exist, but we can say the practical isotropic source which we are using is the omnidirectional source. Hence, for wavefronts to be spherical in nature, the velocity of radiation must be constant at all points as it is in the free space. So if you want a spherical wavefront, then the velocity of radiation must be constant at all points. The propagation medium in which this is true is called as isotropic. Means isotropic, here it means the velocity of radiation is constant at all points. So the electric and magnetic field intensities of electromagnetic waves are very important. The two quantities are direct counterpart of voltage and currents in the circuit. They are measured in volts per meter and amperes per meter respectively. So here the electric field is measured in terms of voltage, volts per meter, and if it is current, then amperes per meter. So for electrical circuits, we have voltage is equals to resistance into current. So here Z means resistance, or we can say impedance. So the electrical field strength can be now calculated as magnetic field strength multiplied by the characteristic impedance. So here we defined electric field intensity as the product of RMS value of magnetic field strength multiplied by the characteristic impedance of that medium. The unit for electric field intensity is volts per meter, magnetic field strength or intensity is amperes per meter, and Z is ohms.